Now I'm going to explain that the moment inertia of this wheel can be measured fairly easily with simply a weight and the ammeter rules. So first of all, let's do the demo. First of all, I'm going to drop this weight is exactly at equal distance equal to 0. Now 3, 2, 1, go. Next, I'm going to explain how to calculate the moment inertia of the wheel, of the real wheel. First of all, because this is a free fall, I can measure the time. So I measure the time 3 times and get an average time is 2.37 seconds plus or minus 0.03 seconds. Well, I've already measured the mass of the wheel and also the mass of the weight, which is 20.2 grams. Then plug into the first formula, h equals 1/2 AD squared, which is basically means that the mass falls freely. So I can calculate acceleration equals to 0.356 meter per second squared. And then let's draw a free body diagram. You can see that mass, field, 2 force, a weight, and also a tension. And for the wheel, so there's a tension 2, which provides a torque, so that the wheel will accelerate angularly. Now I write down 2 formulas. This is the first formula, this is the second formula. The first formula is Newton's second law. The second formula is Newton's second law of rotation. So torque, this is torque, equals moment inertia times angular acceleration. Now because the moment inertia of the wheel is unknown, so I write a value with a symbol x over in front of mr squared, and times linear acceleration divided by radius r, and you can see that this r is cancelled. So the r is cancelled, which I get tension 2 should equals to x times capital letter M A, because T1 and T2 are exactly equal and opposite in direction according to Newton's third law. So with these 2 formula, I can get this the third formula. So the weight is mg, so mg minus x ma, because r is cancelled, should equals to mass time acceleration. And finally plug in all of these numbers into these equations. I get final value of x, which is 0.584. And you can see that these values is very much less than 1 if we are assuming that all the mass is concentrated at the outer edge of the wheel.